We present FluxFlow, an interactive visual analysis system for revealing and analyzing anomalous information spreading in social media. FluxFlow incorporates advanced machine learning algorithms to identify anomalies and offers a set of novel visualization designs to present the detected anomalous threads for deeper analysis. In this video, we demonstrate the application of FluxFlow by analyzing misinformation in Twitter taken from data captured during Hurricane Sandy in 2012. This dataset contains a Twitter feed of 52 million tweets, most of which are noise. Thus, it is important for analysts to identify and investigate critical information in the data, such as anomalous retweeting threads. The FluxFlow system consists of three major components: a data preprocessing and storage module, an analysis module, and a visualization module. The raw data is processed to extract features and reconstruct retweeting threads, then fed to the analysis component for anomaly detection and data organization, and finally sent to the front-end visualization for interactive visual analysis. Here, the analyst loads the top 100 abnormal retweeting threads identified by the FluxFlow analytics engine into the visualization, and wants to discover some rumors spreading during Hurricane Sandy. Notice that those threads are not necessarily bursty or popular as identified by normal trend detectors, but may have considerable impact on certain people and applications. The interface consists of four interactively coordinated UI components, including a cluster view for organizing retweeting threads based on topical keywords, a multidimensional scaling view for projecting data from a high-dimensional feature space to the 2D plane, a threads view for showing temporal patterns of threads, and a detailed information panel with three subviews for accessing low-level data. First, the analyst decides to apply a bottom-up approach, so she chooses to show only the leaf retweeting threads in the MDS view, and selects a number of potentially suspicious threads, such as highly abnormal ones and outliers. Within the thread timelines, one with a high anomaly score and interesting content catches her eye. It says, "Wow, pretty humbling pic at the tomb of the unknown soldier in DC." Through the cluster view, the analyst finds its parent thread containing all threads about the topic regarding a picture of the tomb of the unknown soldier. She observes that there exist multiple peaks in retweet volume, and the user anomaly scores generally transit from low to high a long time. To drill into this topic, the analyst loads all the child threads into the threads view. She can further compare the temporal trends of those threads by easily shifting them to the same starting time. This Tomb of the Unknown Soldier topic, successfully identified by the analyst using FluxFlow, has been confirmed by others to be a rumor propagated during Hurricane Sandy. An analyst can also use a top-down exploration approach. Here, the analyst starts from the cluster view to collapse nodes below a certain tree level. Then she finds one thread with a relatively high anomaly score, and from the tooltip she can see a few interesting keywords, such as power plant, home, and swim. After unfolding the timeline of this node into the threads view, the analyst realizes that this thread contains a lot of users with high anomaly scores, except a few at the beginning. A further visual aggregation of users with low anomaly scores indicates that most of the users have scores above 0.75. By hovering over the child nodes, the analyst finds that the significant burst at the end is actually caused by two of the subthreads, one mentioning power outage in North America, and the other is about a shark swimming down the street. Both of them have been confirmed as rumors later. Further, the analyst wants to see if there are any relations among the participant users in the two anomalous topic threads just explored. So she uses the show duplicated users and show user connections functions, and observes that there are many overlaps. A few people have close social network connections among each other across the two threads. To more deeply explore the threads, the analyst can leverage the feature view to investigate the temporal variations of feature vectors with a heat map-like representation. She can also open the states view to examine the user distributions over the 8 state variables they associate with. To further understand the abstract states, the analyst can change the user scatterplots of the states by setting different rules to the two axes, such as the retweet count and the user out degree. We have presented FluxFlow, a novel visual analytics system for exploring anomalous retweeting threads. FluxFlow combines machine learning-based detection of anomalous threads in big data with a set of integrated web-based visualizations to represent the data and provide for in-depth analysis.